Why does the Pythagorean theorem work? Let's find out. First, the Pythagorean theorem isn't just a squared plus b squared equals c squared, because we actually need to state what these variables represent. So instead, we can say, if we have a right triangle with legs a and b and hypotenuse c, we have the relationship a squared plus b squared equals c squared. Now, there are several dozen proofs of the Pythagorean theorem, and I will show you 3 in this video. Here's our first one. Do you agree that these squares are the same size? Well, yeah, because they are both an a plus b by a plus b squared. A plus b by a plus b squared. So, because the squares are the same size, we can set the area of the parts equal to each other. Now let's start with the square on the left. What shapes do we see inside? Well, I see 4 of the same right triangles and a square. And the area of each of these triangles is half a times b, half base times height. And there's 4 of them. And I can tell that this is a square inside because a straight angle contains 180 degrees, and these 2 angles add up to 90, meaning this angle right here has to be a 90-degree angle. Now let's look at the shapes inside this square. I see 4 of the same right triangles, so we have 4 times half AB, and I see an a squared and a b squared. And we don't even have to simplify. We could subtract 4 times half AB on both sides. And when we do that, we get a squared plus b squared equals c squared. So when we have a right triangle with legs a and b and hypotenuse c, we get this relationship. And we can physically see it over here. We have the same size squares, and when we remove 4 triangles from each of them, we see that the area of c squared equals the areas of a squared and b squared together. Now, for our second proof, believe it or not, we could just use this picture. We can set the area of the parts equal to the area of the whole. So we could set the area of the parts equal to a plus b times a plus b. And when we do, we see that a squared plus b squared equals c squared. Now you might be saying, why did we need the other picture in the first place? Well, we could see it geometrically there. We can't see a squared or b squared here. We would need to do it algebraically. Now, this third proof was submitted by James Garfield 5 years before his presidency. He found the area of the parts of this trapezoid and set it equal to the area of this trapezoid to get a squared plus b squared equals c squared. Now, there was some drama on whether we consider this proof unique, because what I did in proof number 2, that was already well established. James Garfield just cut it in half and then just doubled it later. So let me know in the comments, would you consider this a unique proof, or is it way too similar to what I did in proof number 2? Let me know in the comments.